I'm happy to welcome you all back from the lunch break. I hope the food was delicious. And I'm especially happy to welcome our next two speakers, Felix Reinfurt and Dan Zecha, with their talk, Building LLM Agents, Challenges and Learnings. Even before his job as a senior consultant at TNG, Dan was fascinated with artificial intelligence, as his PhD thesis about human pose estimation already had a strong focus on AI. Since then, he explored all aspects of modern AI systems, from the design of classic machine learning algorithms to innovative architectures for large language model-based agents. Felix is also a senior consultant who joined TNG after his 2 master degrees, one in computer science and one in management. He gained extensive experiences in AI and natural language processing, especially in developing and hosting services for open source large language and embedding models. Dan and Felix regularly offer AI workshop at TNG and implemented several AI services at different clients over the last years. Both have been working on a client project to implement an LLM-based agent and test the boundaries of what's possible right now. This was the starting point for a deep dive into the field of developing LLM agents, which culminated into the talk you're about to listen to. If you have any questions, feel free to raise them after the talk, either by raising your hand or via the Zoom chat if you're attending remotely. So a warm welcome to Felix and Dan.
Thank you very much, Gregor. Welcome also from our side to the first afternoon session at the big Techday 2024. Within the next 45 minutes, Felix and I want to take you on a little journey into the world of large language model-based agents. To alleviate potential food coma a little bit and get into this topic, I want to start with a simple scenario. Imagine the following situation. You're visiting Big Techday from outside, you're not from Munich. Your flight or train goes back tomorrow. You have 1 day to kill. What to do in Munich is the question. Usually you would probably sit down and open Google and see what's happening in Munich. What we are suggesting is to use a different strategy, namely this, which we call a weekend planning agent. I will now start as agent. Don't worry, you don't have to read everything that comes up. I'll point out the interesting parts. The first thing you do is you tell the agent, well, I'm in Munich, what can I do? What you see is happening here looks a little bit like what large language models are doing, right? If you have used OpenAI, ChatGPT, then you may have seen this. There is a difference between what you see here and what a large language model can do for you, and this is coming up right here. What you see is a weather forecast, and this is actually the weather forecast for tomorrow, the actual one. And this is something you probably haven't seen with large language models and chat models specifically. Furthermore, if we continue this itinerary that's being created for us, what to do tomorrow, right? There is a couple morning options, there is lunch options on what to do, and now there comes up an afternoon option, which is, and I didn't know that until I saw it here, the Tollwood Festival, which actually is taking place in Munich currently, right here, with a link. Now, this is something you might not know from large language models, and the question we want to answer is, why do we see this here? How did we do this, right? Furthermore, we want to answer the question like, can this be extended, for example? If we have this itinerary, can we bring this agent, I will define what it is in a second, to, for example, make reservations for us or book tickets, right? Or even beyond that, if you use that agent a couple of times, the question is, can that agent actually adapt to my personal taste? Now, the talk will be a little bit technical, especially in the middle. If you join us with a non-technical background, do not worry. We start very simple with simple questions like, what is an agent? How does it actually work? If you are already in the topic, you might have seen some terminology, some patterns which we like to introduce in the middle of the talk. And then, of course, we have to talk about applications of LLM agents, as well as what we promise in the title of our talk, the challenges and learnings that we have after building several products with LLM, specifically agents. Let's start with the first question. And here is where we have our first challenge. What is an LLM agent? Twitter agrees to not agree on this, and if you ask several opinions of people who work on this, then they will tell you, well, it's actually difficult to define what is or isn't an agent. Felix and I sat together and we thought, this is something that we would agree on, agents as an application that executes some complex tasks, and it does that by combining some key modules like planning, reflection, memory, and tool use. These are 4 terms that we are going to explain during the talk. Now, the concept of an agent is not new. The research in that is much older than 20 years, I believe, but beyond research, we never saw applications that worked in an agentic way. So what changed? Large language models, of course. Large language models revived the idea of agents, where basically the idea is that you use a large language model as the core reasoning engine, and around that you build some agentic workflow. Right? And then people have the romantic idea that this system that you build can immediately solve a bunch of very, very complicated questions, because if you can describe it in natural language, then it's also solvable in natural language. At least this is the idea. And this is the idea we want to put to test a little bit today. To fill this definition a little bit with life, I hand over to Felix, who gets into the inner workings.
All right. So far, we've heard what an LLM agent is, or how we define it, and you also got a little taste of an LLM agent application right in the beginning. Now let me take you into how an LLM agent works. And let's start very simple. On the left side, we have a simple scenario. You have the user query, then you have the LLM, and you get a response. This is a way maybe most of you have already interacted with an LLM. And on the right side, we just put a simple query like, how's the weather in Munich? And what we see as a result is this LLM cannot answer that question out of the box. It says something like, I can't provide real-time information, but it leads us to maybe some websites that we can ask for that. But if we look back to the event planning agent, we actually saw that it was possible, right? And why this doesn't work here is no surprise, because when you think about how an LLM is trained, right, it's kind of trained on a bunch of text data from the internet. But once training is finished, there's no up-to-date information anymore coming into the LLM. So everything that's pre-baked will stay there. But what if we extend this architecture a bit and we introduce tool calling? So on the left side, we now see we added an agent prompt. So we don't want to put the user query straight into the LLM. And we also added a weather tool. And if we now look on the right side, we have the very same query. We say, how's the weather in Munich? Only this time, takes a bit longer maybe. This time we get actual weather information back. So you might ask yourself now, okay, this guy's talking about adding a weather tool to this setup. What does that actually mean? And for that, let me take you on a spelled out journey to actually understand what's happening in this workflow and get a bit more technical on that level. So let's start simple with the user query as we know it. How's the weather in Munich? And then we talked about this agent prompt, right? So if we think about the scenario, what we want to do is we want to tell the LLM that there are some tools that it can leverage, that it can use to obtain external information. And this is what we can do with a prompt, right? And what we see here is one example of how such a prompt could look. And in this case, we say, you are an assistant that has access to the following set of tools. Here are the names and descriptions for each tool. Then comes the tool description. And given the user input, return the name and input of the tool to use. Return your response as a JSON blob with name and argument keys. And if we look at the description that we can actually provide, let's just focus on the 3 marked parts. Like we actually would need to give a description of the tool. So in this case, it says something like it fetches the weather data via an API for a given city. Then we also give the tool a name, get weather in this case, And we define the parameters that it needs to be called with. In this case, a city, which is a string, and it's the name of the city we want to get the weather for. Also, the return type we define as a JSON formatted return value, and this way we have everything defined and put it out in natural language so the LLM can work with it. Okay, now we're set up to make our first LLM call. We put together the agent prompt and the user query, and if everything works right, we get back something like this. So we have the name of the tool, get weather, and we have the arguments that need to be passed to that tool. And here you also see the LLM inferred from the user query that the correct argument in this case would be Munich. So far, so good. Let's go to the next step, because now, what's the benefit of having such a structured output, JSON in this sense? We can easily parse it, and then, in this case, search for the name of the tool, get weather. If we have it in our program, we could execute it with the parameters provided. And in this simple scenario, the weather tool is basically just a wrapper around an API, and Munich is the query that's then passed to the API. And we see the tool output then. So we see the coordinates of Munich, that looks fine, we get the weather, and we also get some temperature information there. In theory, this would already suffice, right? We could answer our question from the beginning, how's the weather in Munich? However, this is a bit clunky and maybe not so nicely human readable. So in most cases, you would want to go through a second iteration through an LLM call to make it more human readable. And that's what we do here. So we also have an answer prompt that we create saying, you are an assistant that answers questions from a user by utilizing tools. The tool that was used is described here. We put the call tool, and its output was the following. Given the user input, generate an answer that is informed by the used tool and its output. And as I said, this is just an example. You might also just provide the output, but this way you might also have the possibility to check whether it actually makes sense what tool was called and the output. So it gives you maybe a bit more robustness. Then we come to our second LLM call, and then we get an answer like the current weather in Munich is light rain. This was done a few days ago, of course, with a temperature of so and so many degrees. And then we would route it back to the user. Okay, so now for a very simple scenario, you got kind of an idea what tool calling, or also called function calling, is about. And this simple scenario can, of course, be extended because with this sort of setup, you cannot solve many problems yet. And this is where we get to some other agentic design patterns. So there's quite some proposals out there on the internet of how you would build an agent, what architecture you would use for it. And there's also some patterns that you can distill looking at them. And we want to give you some patterns. We want to show some patterns so that you can use them also to kind of construct your own architecture. Because certainly, depending on the application, it's going to be very individual what kind of architecture you need for your agents. Okay, so that's where we stopped. And how could we extend this architecture now? At first, I mean, we only had one tool so far, right? There was not much of a choice to select from. Let's add some further tools. So we have a restaurant tool, an event tool maybe, when we think about the event planning agent from the beginning. And we also add a tool handler, maybe just an abstraction that's capable of parsing what the LLM returns, calling the tool, and also handling errors maybe. The thing about the tools in this setup is when you build agents, basically they help you to obtain additional information, right? Information that the LLM doesn't have on its own. So kind of the use case or the problem you want to solve depends largely on what tools you provide. And Often these tools are API calls, so it also depends a bit on what APIs are out there and whether they fit your use case or not. So there's something to remember and what might limit also building agents at that scale. Furthermore, you would want to have an LLM that's actually doing quite well on function calling, as we introduced it, like being consistent and reliable in detecting which tools should be called and which parameters should be provided. And you can imagine if you provide more and more and more tools, might also be more difficult to select the right one. So it's unclear how that would scale for arbitrary many tools. And maybe a last note on that one, there's of course also distinction whether you use commercial LLMs like the ones of OpenAI, for instance, or the like open source ones. This case that I showed now, like the really spelled out version, I actually used an open source one from Mistral, so they also work in certain scenarios, but might be a bit subpar to the state-of-the-art ones. Let's go a step further, and instead of just going through one iteration, we of course might have more difficult problems that won't be solved with a single tool call. So we just need to iterate back and maybe take a second tool call or a third one to answer more complex questions. In a further extension, let's look at memory, or more specifically in this case, conversation history. So this is for most currently a no-brainer when you think about chatbots, right? So especially when you have the outer loop, the user query and response, and if you think back to the event planning agent, if you want to kind of change the initially proposed itinerary, you might want to interact, and then of course you need to know the conversation history. But also if you are inside the agent and have several rounds of tool calling, you might want to track what happened, right? Because also if you solve a problem that you broke down in steps, you want to know what happened at the steps previously. A further extension to the setup might be a planning module. So when you remember, or Dan only shortly showed it, of course, in the beginning, but the event planning tool actually, and this was like externalized, we helped also in prompting it that way. The event planning tool provided some sort of planning steps that it would take to solve this Saturday planning problem, checking the weather, finding activities, finding events, and so on. So this might be a good idea to incorporate in your agentic architecture. So you break down the complex problem, maybe in sub-problems, then you can more easily kind of work on them separately, come back, and maybe also, depending on the outcome, change the plan if needed. Another module that could be an extension to your agent is a reflection module. So if you think about solving a problem and kind of going through first iteration, you might want to kind of reflect on it, like, did I actually do what I planned to do? And LLMs can be used to achieve a similar thing. Like, once you get a result from a tool, you might reflect, okay, is that actually correct, or do I need to change my plan now accordingly based on what came out? So this gives a bit more robustness usually. You also have prompting strategies you might have heard of, like a chain of thought or something, where you kind of try to give the LLM more time to think about what it's producing. This reflection step could be seen as a sort of extension to that. Now, when we think about just one agent, we could also think about multi-agents, right? And I want to show you this sort of architecture, kind of high level. We have that from LangChain, one of the frameworks out there. So this is the way you might often see this architecture sketched out of, like, you have kind of this supervisor, and then you have different agents that are capable of certain things, and you're going to route the sub-problem to the agent that is most suitable to it. And Dan and I actually favor a bit of a different modeling strategy, because these additional agents could, in our opinion, also be modeled as just another tool, maybe a bit more of a complex tool. Maybe that tool has, then again, tools that it can use, but in this case, when we think of a booking agent, it might be a bit more complex than just one API call. And if you think about these kind of agent and sub-agent system, you can, of course, go on and on, right? And you can create hierarchies. But what you should consider here is that you're also adding a lot of overhead in communicating between these agents. How do you share information? You also, if you think about the outer user interaction loop, you give kind of the control flow away for longer. It might take longer until you get a response back. And there might also be more steps that could lead to errors on the way. So these are considerations you should be aware of and think of when you introduce multi-agent setups. One aspect that could help, and this is also something that you see now a bit more and more coming up, the human in the loop, not only on the outer loop, as I introduced already, or as I just mentioned, but also kind of being able to, within one of these agent runs, like kind of get into the right position and maybe change things. Let's imagine after the planning step, like a plan was made, and you are able to kind of look at it and maybe give your feedback in the sense of, okay, this is not what I imagined, this doesn't make sense, maybe adjust the plan accordingly. So there's certainly one place where you could interject. Then regarding the tool calling, you might also want to check out which tools are called, and depending on your knowledge of the problem or how to solve the problem, you might steer it a bit of saying like, these are the wrong tools maybe, or rather take this tool call. And similarly, you could kind of hook or create a hook for whenever a certain tool is called. Let's think about the booking agent. There's probably going to be some real-world interaction, right, if a booking is made. Maybe not everyone would trust, like with I don't know, credit card information to these systems. So you could say, okay, always when this tool is called, you need like to press a button or something, like you need this approval step. And lastly, on the way back, after reflection, we could similarly interject and say, okay, I don't think your reasoning is correct. Let's take my input and use that one in refining the plan. All right, so this is now, we gave you some design patterns now at your hand, and you can use them to construct these sort of agents. And it's like, this is high level, right? So if you're actually gonna implement these agents, there might be more questions coming out, might be more fine-grained and nuanced decisions to make. But this is kind of a tool set that you can use, and Dan is going to tell you about applications of LLM agents that also make use of these patterns.
Yes, thank you very much. And we are going to go into the application field with actually one application that I would like to show you, which is an agent that we built specifically for this event, also a data science agent. What's the job of this agent? It's a program where we say, okay, here you have some data on my folder, on my local machine. Please solve a regression task on that data. So what should this agent do? You see the data on the right side, some sample of the data, and the idea is basically that that agent should predict the values you see on the rightmost column, right? And based on the values you see on the left side. So quite a simple thing. You usually learn that in university. And this is what we implemented. And for that we have to, this is now the agent that Felix just showed, and we exchanged a couple of things here. The first thing we did is exchange the tools. The tool set is completely different now. The idea is that this agent has to have certain abilities. For example, look into certain folders, right? I said the data is just there in the folder, do with it whatever you want, just solve the task. So there is a file inspection tool where basically the agent can open up a folder, look into the folder and interact with the files it sees. It usually does that by writing some code, in this case Python code. It has to come up with that Python code itself, but then is allowed to use a tool to write that Python code to my disk. And it is allowed to run that code with an additional tool. This is done in a virtual environment, and within that environment the agent may want to install certain packages it needs to run the code, and we'll see an example of this. We also extended the agent in a different way. We haven't spoken too much about the concept of memory. That's usually also a topic when you think about agents, and in this case what we did, just because we wanted to try it, is basically extend the planning feature of that agent with some storage. And in that storage we had past analysis, so analysis that was done by, in this case, a human. So the agent could look into that and see, okay, this is a similar case to what I solved, and derive a plan for solving the new problem from that storage. You don't need that necessarily. You can just let the LLM do your planning. It will be much, much more inefficient then. Now, I will show you what this agent does. In a typical computer science manner, you will see a command line. Do not worry, you cannot read the command line. It will be running in real time. I will point out a couple of things though. So we see the agent running on the left. On the right, you see my folder structure. There's two files in that folder structure, training and testing data. The agent doesn't know which is which. I just put it there. The agent now starts running. And what you see is that in blue, the agent formulates thoughts. So what do I think the next step, what's a good next step? It will then try to call a tool. This is what you see in yellow, and in green you basically see the answer of the tool that the agent can reflect upon. In this case, it started to write some code to my system and wants to run that code, but notices, hey, I'm missing a library, and it's installing that library in real time right now. Right, and after that goes through, the agent then decides, okay, I might to rerun the code again and see what comes out of the code. Now the library is installed, and the code that's actually written, the file says load and inspect data. This is something that the agent chose itself. So it basically used some code to open these files and get some statistics from the data in the files. And then it uses this to reflect upon, okay, what's the next best step? Right? We also pipe in errors that appear a lot, not from our code, but from the LLM actually. We also pipe that back into reflection steps. So the agent goes through a plan, but it might choose to do other things during executing the plan. Now in the end, and we will not watch this because it takes a couple of minutes, in the end what will happen is that the agent will basically save the best model it found, right? It has to solve a regression task, and it will also provide an error value, an error measure. So how well did I solve that problem? And we thought that was quite interesting and thought, well, how well does that agent actually perform if we compare it to us? So, a little bit of a battle, man against AI. We formulated some rules of engagement. The idea was the man is me, the AI is the agent. We start on a green field, so nothing is installed. I did not have a look into the data itself. I opened the data and the time starts. The task is develop a regression model that predicts the data very well, provide an error measure in the end, and stop criteria. This is a little bit difficult in this setup. We define it as if we are happy with the result or believe that we can't improve any further, right? Or the time you have to invest to improve any further is just too much, and so just let's break it off. We see a graph here, the time in minutes on the x-axis, on the y-axis we see the error the model and I did, and error means lower is better, right, in this context. Now, where am I in this graph? This is me, 27 minutes. It took me 27 minutes from opening the data, having a look into the data, understanding the data, developing an idea of what to do with it, training the first model, iterating over that model, doing some fine-tuning on that model, and at the end I came out with something where I said, okay, I think I should stop now, I can't improve it any further, let's stop here. What do you think where the agent is? Here. First good message, the agent is not better than me. The difference between the agent and me is not that big. The problem is quite simple. So it's nothing to worry too much about. The thing I can't really talk away is, of course, the time. The agent only used 5 minutes to solve this problem up to a certain degree where it said, okay, I can't improve anymore, I'm at the end of my plan, I will stop here. And that's considerable, I think, right? So where we currently are is the third trial I did, and here in the first try I limited myself only to use Google. In the second trial I said, okay, now let's see how fast I can get if I do the first analysis again with ChatGPT. This is where I land. About the same error measure, only half of the time, which is a very good reason why using LLMs in development work may be a good thing. Now imagine if we use agents as tools, insert ourselves as human in the middle, how much faster that even could make us, if done correctly. Now, this agent falls into a class of things we see currently where we see a lot of movement happening. Most of the things being developed right now you see in the coding and debugging area. We screenshotted a couple of agents. You see Devin in the left top, small developer, SWE agent, GPT engineer. There's many more. All of these frameworks do one thing. They write code in some form. All of these frameworks, most of them at least, had their very big 15 minutes of fame, and then we really didn't hear a lot about them. To our knowledge, none of these frameworks is really in a state where you want to use it as a product if your income depends on it, currently. Another big area where we see things happening in terms of agent is, of course, search, huge economical impact. The example you see here is Perplexity AI, where you can basically enter a question, and what Perplexity will do is search the internet, and from the results it gets, do a re-ranking, summarize the results to a very concise but complete answer. In this case, what is the TNG Big Techday, and it will provide you with links, which is something that LLMs don't do, right? And then you can use human in the loop to refine your question and to come to a conclusion that you want to see. Very big thing. Microsoft has something similar. They inserted, I think, Copilot into Bing. Google is working on something similar. So there's a lot of things happening in this area because, of course, the economical impact of good search results. The fourth category we see is personal and educational agents. If you look for AI tutors or AI teachers, so basically AIs that help students cheat on their homework, there's a lot of money in that field currently. In this field, we would also put the simple example you saw, the event planning agent. Initially here you would also find Siri probably, which Apple announced will be combined with some form of LLM. And what I also added here, it didn't make it into this call, is another agent we wrote some time ago. This is a blog post from February, where we basically wrote an agent that can negotiate meeting requests. The idea is you get an email where someone tells you, hey, this and that topic, I need to talk to you. And then the agent could answer that email directly, back and forth, as long as necessarily, while having access to your own calendar. So it basically can negotiate a meeting without me having to interfere in natural language. And the fourth category, of course, we see a lot of development in the field of robots. This is a very interesting thing because as robots are more usable and move closer to humans, there is the necessity that they also can communicate better with humans and work together. Using agentic workflows is one way to achieve this. We have an example here. These beautiful looking nerdy people are colleagues of ours who recently had the chance to work on a Boston Dynamics Spot robot. They used this robot, combined it with an LLM, with a retrieval augmentation pipeline. They also added some text-to-speech and speech-to-text transformers, and in the end, basically, you could go to that robot, talk to it, and it would talk back and explain things, and you could walk around and communicate with the robot. Very interesting fields. I think we will see applications like this much more often in the future. Last but not least, I promised to talk about challenges, learnings, and considerations when constructing these things. And there's three, to the things that we've already said, there's three things basically we want to add, important lessons that we learned. Lesson number one, agents are notoriously difficult to debug. Right? I can't tell you how often you face the situation that what you get back from the LLM, and I'm talking also about the top LLM providers in the market, what you get back isn't even parsable, right? And if it's parsable, it doesn't make any sense semantically. The reason for that, of course, is mostly hallucinations. Hallucination is the output of a large language model that is wrong or you wouldn't agree with. And this leads to many, many failure cases. What do we learn from that? Interestingly enough, I created this image with ChatGPT. Hey, give me a be aware image. I can't help but notice that this very well underlines what I just said about hallucinations. The thing that we want to tell you is be aware that this can happen. Assume the worst and adapt to it, right? This is the right strategy. Assume that these errors will happen and find strategy to deal with them. In the data science agent, what we do is if there's something from ChatGPT coming out that we can't even parse because it's not a valid JSON, we pipe it right back, right? And let the LLM reflect on that and produce something that's more valuable to us. So heavily invest in guardrailing would be what we suggest here. Of course, let's look into the future. We can assume that these things will get better over time, right? Model capability is going up. Over time, we will find better ways to fine-tune these models, to do better function calling. If you have the capabilities to fine-tune models, it might be an idea to think about, hey, maybe I don't want to pipe in my company knowledge into an LLM, but I want the LLM to do something specifically very well, for example, function calling. Right? And this is what you might want to think about if you have the opportunity to do it. Second, very, very big thing, evaluation is as hard as it is important. Little story here, we recently had a call with a customer. The idea was the customer wanted an LLM agent from us. And what we do in the first kickoff session is usually talk through the steps, and one big step is always evaluation, right? So we asked them, okay, how do you actually want to evaluate what we deliver to you? How do you know it's good? It's an agent, right? And the answer was quite straightforward. The answer was, I know it's good once I see it. That is, in our opinion, not a really valid evaluation strategy. However, it's a very understandable sentiment, because sitting down, defining what your agent should or better shouldn't do is really difficult and takes a lot of time. So it's understandable that people tend to avoid it. What doesn't help is the lack of proper benchmarks. If you look for benchmarks for agents, you will not find a lot. What you find is mostly coding stuff related. Even if there were benchmarks, if you want to develop something completely new for the market, you will not find a benchmark to test it. What's the learning? Very simple. If you want to prove to people that the agent you build is actually working, there ain't no such thing as a free lunch, right? You have to sit down, you have to consider what works for you, what doesn't work, and act upon it. If you look at the tooling you have for that, we are not where we should be. So the question is always, if you have a strategy, how do you actually evaluate if it's working or not? You need some tool that tells you, well, the agent output is good or not. There is strategies, namely using large language models as judges. This works okay-ish, could be better, right? Looking into the future, what we expect to see is that these tools get much better. We understand much better how we need to evaluate things. What we will have forever is thinking about the actual evaluation strategy, right? This is something you need to do. Last but not least, third point, deployment. Within the agent hype cycle, we believe that we are currently still in the research and demo phase. We do see applications coming out every week, and people who want to sell them tell us this is a finished product. Yet, almost no one's using them for their sole income, right? A number you hear every now and then when you talk to people or listen to people who work in that field is about 60 to 70% of my problem I can solve with an agent without too much effort. From that point on, it's really hard. Now, the question is, would you deploy something that only works 60% of the time? The answer is probably no. What we found is a good workflow when developing agents is this. The idea is you initially break down your agentic workflow into things. So you have to understand your process, you have to break it down. For that process, you use the LLM only where it's really necessary. Because, of course, we want to have the power of the LLM, but what you don't want is the uncertainty that also comes with it, right? You need to minimize that somehow, so there is a certain balance you need to find. What you will find is that whatever you read on the internet about general architectures will usually not work. What you will be building instead is something that is heavily over-constrained and very, very specific. But for that reason, that agent will be working actually, right? For your small problem, but within that problem domain, you will have some outputs that are actually acceptable. The idea is to deploy these agents early on to a test user group. So you know you have a product that is not perfect, but deploying early is important for mainly two reasons. A, you gather feedback and really understand what your users actually want with agents. If you look at what people type into agents, it's crazy what people expect from these agents. This is something that you will understand much better. And if you use logging properly and log input-output pairs, what you do is, with this data you gather, build a proper evaluation strategy. And in the end, rinse and repeat, right? What we do with good software development anyways, and with machine learning systems specifically. That is what we wanted to tell you. We hope you have a little bit of an understanding about how the things you just saw work in real life. Maybe even you have an idea on how to code your own agent for whatever use case is in your head currently. And after talking 45 minutes, we'll give it to you for questions.
Thank you, Felix. Thank you, Dan. Now we have 50 minutes left for questions. So I think you are... So please use the microphone so the remote...
How do you reflect?
How do you reflect is the question. Oh, am I on? Yeah.
Am I on? Oh.
How do you reflect? Various strategies. Actually. So I can give you an example with the data science agent. What happens is that this data science agent has a plan wherever it gets that, right? Initially it thinks about, okay, what might be the steps I want to solve? It then starts going through that plan. What happens is, of course, that there are things that happen that you don't expect. It happens all the time. If I do such an analysis, I all the time find things that don't work. And what you do is basically, what you can do, I'm not saying it's the only way, is basically you look at whatever your tool returns. So you build an environment where the tool can also return success or failure cases. And this is what you pipe back combined with a proper prompt. So there's some magic happening around it. Usually depends heavily on your use case. And you pipe that back. And then you give the LLM the task, okay, this is what you wanted. This is what actually happened. This would be your next step. Do you still want to do the next step, or do you want to react whatever happened?
Please, the microphone.
So you basically ask it again to iterate through the result and say, evaluate now the result in a new planning session. And
yes. So for in this case, you saw it's just like one step, like one block of text is actually two steps. It's like, this is the problem you want to solve. This is the tool I'm using. And then let's look at what the tool actually gave us back. Is there something we need to do, or can we go on with our plan? Or do we need to change the plan overall, right? So this reflection back on, am I still doing the right thing? Am I still on track? Is something that you just ask, or you assume that the LLM will answer correctly and reflect correctly. Of course, doesn't always work in reality. Right.
Thank you. Next question.
Hey, thanks Dan, thanks Felix for your talk. You told us that you can put multiple agents into the same system, and also there is this approach that you actually form a graph of agents where you have essentially a state machine of agents, and you formulate how what the state transitions are between those agents, just to formulate a little bit more complex workflow. My question is, you told us middle of the talk that you prefer actually to formulate agents as tools versus this state graph of agents. What's the considerations behind that?
Yeah, I can take this one. So basically, they are equivalent. I just think that with this, how we build up our architecture, it just makes way more sense to kind of incorporate it as a separate tool, because of the way I showed this in between, the LangChain way. It's kind of not fitting into the way we build things up, and it's in the end equivalent, because you just see it as the orchestrator. You could see our agent that we described, and then you have tools, but they might not all be called agents. I said, okay, maybe let's say an agent, another agent is a bit more complex, not just an API call. So in this case, we could show it in the way of living next to other tool calls where you can more easily kind of retrieve the information you need, if that makes sense.
Also, what this adds is another constraint. I talked about constraining agents so that they actually work. By adding it this way, this adds another constraint, right? The booking tool can't be called in some arbitrary sequence, but usually someone decided, okay, I need a booking tool, now let's call it, versus if you have a group of agents and some magical entity that controls them, this edge usually adds another constraint to the problem. Thank you.
Thank you.
One question from my side. When you wrote in your previous slide that you break down the workflows, is this then a kind of planning, what I inject as knowledge inside the agent?
Yeah, so it could be as part of the planning, but you could also think it further. Like, okay, let's first the planning maybe, because as Dan mentioned, you kind of have this romantic notion of an LLM now being able to solve tasks. But I can tell you for the event planning agent, when you really leave it to make the plan itself, always like you get such a variation. So what helps is to at least give certain constraints, like not tell, okay, you always need to do this and this and this, but kind of ground it a bit, limit the options to get it more streamlined in that sense. But the other ideas that and this might go in the multi-agent direction. We don't have too much hands-on experience on that, but the idea is that you could have these multi-agent breakups of how you would solve a problem, maybe analogous to a team of humans solving or working on a problem. And then within these, you limit really what the LLM can do. And you maybe also what we heard in the previous question, like when you build a graph, you maybe just use the LLM to kind of route in the graph, but what happens in the graph, or on one node of the graph, you have a lot of control about. So you can better control overall what's happening in the system.
Then one follow-up question to this. How do you represent the planning? Is this only the LLM which does the planning, or did you also try it out to use some basic programs that you do the planning, or some JSON? Or?
Could be, and I mean, Dan mentioned it with the expert knowledge that we hooked up, like a database. So it really is dependent on your use case, and but both are valid ways, I would say.
It really depends on your use case. Where I mentioned the data science agent basically creating a plan from some past knowledge ahead, you can leave that completely out. You can basically prompt the LLM, in this case, hey, generate a plan to do it. And we did that. What happens is the error gets worse, so it performs worse. The second thing that happens, it takes much longer, so time and money, right? This costs money to run it, and not just a little. And the reason for that is being that these general plans that LLM themselves can produce are usually, I would say, average at best, even for simple problems like this. So it will try to do a lot of things that aren't really necessary. This is what we found. Yeah. So the planning, this is, by the way, one thing that people believe agents can do, right? You describe something, it comes up magically with a plan, because people think that LLMs are able to plan and reason. And I would say there's at least a big question mark behind that, right? To be discussed.
Yeah, thank you.
Are there any questions on Zoom, maybe?
Yeah, it actually just came in a few minutes ago. If I would like to build my own agent to play around, would it make sense to start from something like LangChain or other tools? Or should I start from an LLM like Llama and build everything around it myself?
Yeah, so I can take that one. So in the question, or it was formulated the way that that person wants to play around. So then I would definitely recommend like getting a head start and using these frameworks like LangChain, Llama Index, and so on, because they just make it easy to see something right away. But for instance, for this walkthrough of the LLM call, I implemented myself like bare bone, because these frameworks also abstract a lot away from you. So it's more difficult if you actually want to know what's going on under the hood to figure that out. And you also have the next level then, like on top of LangChain, for instance, tools or frameworks like Crew AI that go a step further and say, okay, you just define the agents, give a bit of like context history to this agent and tell how it interacts with other agents or which tools it can use. And then you kind of put together your network or your graph, and then you hands off, go. So this is like, yeah, it could work in theory, but if you actually try it for more complex problems than just like writing a research paper or something, like then it derails so easily. And then my critique is that these frameworks are just hard to really tune and to fiddle at the right points because of this abstraction. And currently, at least, this human-in-the-loop aspect that I talked about is not so easily to implement with them, but just recently, it's getting more and more, especially LangChain, Llama Index, they are investing more into making this possible for also a good developing experience to be able to kind of capture the entire state of a run. Then you can jump to any of these states, you can see what was the state, you can alter the state, pick other tools, like pick other actions, and kind of be like better iterate and develop your agent that way.
Maybe some questions from the back of the audience? No? Okay. Any more questions? Ah, Zoom again.
Yep. There are actually two more questions, but I start with the first one. Essentially, what are the basics I need to learn before I should even touch any LLMs? That's one of the questions. I think it's a very broad one, but okay.
That's a very broad one, yes. Go to university, study AI. Read a lot of books, do a lot of projects, do everything you can get your hands on. Hands-on experience is undervalued.
Listen to Grant Sanderson's talk later on.
Listen to Grant Sanderson, yes. Noam Brown also.
And then maybe the second one as well. Can you work with these LLMs in a PC? So essentially, does it work on your local machine? I think that's the question. I guess I don't have any further information.
I mean,
Yeah.
Take it.
Yeah, in like principally, yes. I mean, there's these approaches out there where you can also make inference on your local machine, even on CPU if you don't have a GPU, right? But these are then usually smaller models, quantized models that are not as capable as the others. And you, as we brought hopefully over in the talk, that one central capability of your LLM should be function calling capability. I have no experience so far how well they are, but in general, even if you don't scale down to run on your personal computer, the like 7B model families, they are not super strong. Even the bigger ones, when we talk about open source, for instance, because these are the ones you can run on your machine, right? They are, even the larger ones are not that strong always. However, they are really fine-tuned ones, like I can drop one name, there's like the Gorilla LLM. It's from one of the big US research institutes or universities, and they seemed like they have a smaller model, I think in the range of 7B parameters, and that's doing pretty well on function calling capability benchmarks.
We have time for one very short question.
I have a kind of provocative question. I have heard that the cutting edge of this technology is GraphRag, and Microsoft recently announced their product for this, and they have a default size of the running window of 300 words. And it means that all what you can achieve here is, it has to be inside of these 300 words. If you have something larger, then you cannot do it. And then we are limited with these 300 numbers of words. For me, it looks like really small. I cannot fit an abstract in 300 words sometimes. How is it developing? Was it 100 1 year ago, and then 300 is a huge achievement, or we are limited here and we will not be able to do anything more complicated like weather forecast or booking?
So I don't. So you said something about GraphRag or something. So I'm not familiar with the concrete problem. And 300 words, like in the current context, does seem like quite low, to be honest, because we did start with small context windows of these LLMs, but that would be like 1K, 2K. Meanwhile, like even the open source world is like 32K and above. And if you go to the third party vendors like OpenAI, Anthropic or so, you even have larger context sizes. So like the 300 is a bit low. Maybe we can, like you can explain or show us afterwards what exactly you mean. But if you're really talking about context size of LLMs, that's like far above. So the problem used to be there a year ago, but it's less of a problem today.
And one of the reasons why, for example, the data science agent actually does something useful is because we use a lot of context size. So this wouldn't be working if we used a smaller open source model.
Unfortunately, we ran out of time, so thank you, Dan. Thank you, Felix, again for this wonderful talk.